Hey, good people. We have finished the graphing trig functions. We've graphed sine, we've graphed tangent, graphed secant, cosecant, cosine, and cosecant. One of those. We finished all 6 trig functions in the graphs. So the last part right now with the trig part is knowing your identities. So we're going to start off with the basic identities this time, and there's a good number of them in here that you're going to have to make sure you know. Not just, oh, Mr. Hall, like we had in our notes, I can just look back at my notes. We need you to know them. So make sure in this that you know these identities, because if you don't know them, when we get to having to verify and everything, you will struggle. So do not struggle. So I'm going to say this again. Know your identities. If you don't know them, you will struggle. Like, struggle is good. You will struggle if you do not know them. So you don't have to write that part down in your notes. But with this, it's very, very important that you know your identities. Know them. Know them. Know them. Not know about them. Not cram them in your head and be like, well, I'm going to just keep them for now. Know them. Because you're going to have to know them in order to make sure that you can do the verification and stuff later on. But okay, let's move on to example 1. And here we're going to talk about something that we did before when it came to our unit circle and our trig values and all that great stuff. So here, example 1, and again, if you need to stop it, go and stop the video and then write this down. And then we're going to go through it. So I'm going to stop. And then here we go. So example 1 says to prove that sine x cosine x equals tan x is not a trig identity by producing an example, counterexample. Now, just to give you an idea and understand, whenever we talk about trig identities, any identity that we have means that it's going to work no matter what happens. So like 1 plus 1 is always going to equal 2. That's identity. It will never change. It will never go away. It can't flip to something else. 1 plus 1 will never equal 3 or 4 or 10 or anything of that sort. It's always going to be 1 plus 1 equals 2. So all the identities that we're going to have, one side of the equation is going to equal the other side of the equation. No matter what happens, it's always going to equal each other. Now, this one right here, we didn't say this is an identity per se. We're saying that we're going to prove that it's not a trig identity. So that means sine times cosine equals tangent is not true. So it could be true for some things, but not true for all things. But here we're going to prove where that is not true. So let's go ahead and take a look at that. So it says again, prove that this is not a trig identity, which means one side does not equal the other side every single time, like an irregular equation. So let's just choose something. Let's say x equals pi over 6. Ooh. Let me fix that. Say x equals pi over 6. Now here, again, it says find a counterexample or produce a counterexample, pretty much where this does not work, where this is not equal to each other. So we're pulling a value for x, and we're saying, okay, let's just try pi over 6. That's a value for x we can substitute in, and we can see if it makes both sides equal each other. If it does, it's not a counterexample. If it doesn't work, that means that if the left side right here of the equation does not equal the right side of the equation, that means that it is a counterexample, which makes it not an identity. So let's go ahead and do this part. So we'll do sine, my fault. So we're going to start off with sine pi over 6. Oh, Jesus. Let's fix this really much. Pi over 6 times cosine pi over 6 equals tan pi over 6. Now with this, you should remember what your trig identities and stuff are because we have dealt with this before. We've dealt with sine pi over 6. We've dealt with cosine pi over 6. And we dealt with tangent pi over 6. So you're going to have to remember those values here and not put in a calculator because you might not, for this section, 9 times out of 10, you won't even have a calculator for this chapter. So here, again, know the values. This is why we've done this before. So let's say we're using pi over 6. So pi over 6 for sine, if we look at our unit circle, we look at the graph itself, we know that's going to be 1/2. And if we look at cosine pi over 6, again, either looking at the unit circle or looking at the graph, we know that this is the square root of 3 over 2. And again, you have to know those values. Know them, because if not, then this is going to be, not good for you. All right, so then at this point, we look at this part here, tangent pi over 6. And remember, tangent, same thing as saying sine of a cosine. So it's this divided by this. So we should get square root of 3 over 3, right? Right. Okay, so if we were to multiply this out, multiply straight across, so 1 times square root of 3 is just square root of 3, and then 2 times 2 is 4. Does that equal square root of 3 over 2? Or 3 over 3? Sorry, let me do this. A question mark, because we're not sure exactly with our values and stuff. So does that equal? So we're putting question marks there to say that we haven't verified it yet, whether it's right or wrong. So here we know that is not. So we have now given a counterexample of where this identity is not true. So therefore, since the inequality is not true, the equation is not an identity. So let's write that out. And with that, I do want you to write it out. If I give you this like on a test or something, I want you to write it out so you will know that it does not work, or you can tell me that it does not work, so therefore it's not an identity. Okay, so again, this is important that you know your values. That's why we hit this hard. That's why we went to the unit circle. That's why we talked about the values, and I had you do sine of pi over 6 and sine of 5 pi over 6 and all these different functions of cosecant and tangent and cotangent, all that stuff, because it's important that you know it here. All right, so we're going to go on to more notes and everything, and then we're going to go to an example, practice this later on. All right, talk to you later.